Good afternoon. Welcome everyone for this joint webinar from EDS Technologies and Dassault Systems on strategic mine plan and maximization of mine profits. So first of all, I would like to take this opportunity to welcome everyone for this webinar. First, I would like to introduce our anchor for today's session, Mr. Pramod Sarangi. Mr. Pramod Sarangi has over 27 years of professional experience in the fields of geology and mine planning in overcast and underground mining exploration and production planning operations. He has more than 6 years of experience in customer service, sales, and support of GEOVIA software products and Dassault Systems products. He is currently in EDS Technologies working as a General Manager Technical with more than 8 years of experience in customer service, sales, and support for GEOVIA products in India. He is also a competent trainer of GEOVIA products in the areas of geology and mine planning. Before handing it over to Pramod, I would request the audience during the course of the webinar, if they have any questions or if they have any queries, they can type the same in the question box. We shall take it up at the end of the webinar during the Q&A session. Thank you. Over to you, Pramod.
Yeah, thank you, Away, for introducing me and our team. So welcome all again to the webinar. So hope definitely this webinar will helpful for your mining operation. So before going to the webinar, I just introduce my organization about our activity and our solution we are providing to the customer. So we are the value-added partner for Dassault System, and we are having our number of mining customers across India, and our focus is on customer satisfaction and flawless execution and accelerates time to market cross-vertical solutions. And we are also bringing new technology adoption to the different industries, including mining, and focus on innovation. Apart from that, for the mining organization, we are having our e-learning platform where you will find the e-learning solutions for Surpac and Minex. And we are having 27 plus years of service experience and 200 plus associates. And we are having 7 offices across India. Next. Coming back to the mining at the rate EDST, so we are engaged in mining solutions, sales support and services in the mining industries, and we are having a team of highly experienced geologists and mining engineers to provide technical support solutions on GEOVIA suite of products. And we supported 100 plus mining and consulting and academia customers, and we provide support to customers in different commodities like iron, manganese, bromide, limestone, gold, copper, and coal. Next. So in this particular webinar, we are having another 2 eminent speaker from the mining as well as from the OEM point of view. So I am introducing our one of the speaker, Mr. Madhavanand Acharya. So he is the AGM, Assistant General Manager, Geology and Business Development in MSPL Limited. And he is having worked previously in Vedanta, BHP Billiton, Hindalco, and Gemfields. And he's having more than 15 years of professional experience in mining geology, resource geology, which includes brownfield and greenfield projects. And he also involves in the strategic planning, natural resource development, and management. And he is specialized in resource modeling and mine planning software like Surpac and Whittle for pit optimization. And he successfully completed the professional development course on Indian Mineral Industry Code IMIC and attained the eligibility to obtain the RCP certificate, registration competent person of NACRI. Welcome, Mr. Acharya, for the webinar. Next. Along with me, another eminent speaker is Mr. Amjad Basa. He is the industry process consultant in mining. He from Dassault System. He is the OEM of the particular software what we are going to showcase today. He is a mining engineer and currently working as a mining industry process consultant in Dassault System. Has over 12 years of experience in mining operation, long-term, short-term planning and scheduling, mine planning solutions, implementation, training, and consulting. So now I will hand over this particular session to Mr. Amjad, Mr. Acharya to discuss and share his experience on this particular webinar, what we are going to showcase on the strategic mind planning. And if any questions, if any you require any further input, please feel to contact us at the end of the session in the question and answer session. You can write there is chat session is there. Okay, over to Amjad and Mr. Acharya. Thank you.
Thank you, Pramod. Thank you, Amjad. I just introduced Dassault System. I'm Nitin Jain from Dassault System as a partner sales manager. I take care of GEOVIA sales business across India. And along with me, Mr. Amjad Basha, he's take care of all India GEOVIA technical part. So I just, for the today's presentation, these are the agendas what we are going to cover. As a corporate introductions, I will take just only 2-3 minutes time. So will not take much time because as I understand, this is a more technical sessions and everybody is looking for the technical what we will get it for the today. So I request Amjad means in fact we encourage everybody to more participation in this webinar so that we will get more information from your side and we will give you the more right appropriate questions and answers to you at the end of the sessions. So just briefly, I will introduce Dassault Systems. As a Dassault System, we are a process-driven company. While we saying the process-driven company, it's basically we are encouraging our customers through a 3D experience platform for imagining and sustainability innovation capability and harmonizing the product as a natural and live. And globally, we are more than 20,000 plus professional people in across the worldwide. We are present at almost 140 nations in worldwide, and we have one global R&D center and 69 R&D labs are there in worldwide. We are long-term driven company, and majority of our stakeholders is wife family-driven owned company. And we are our revenues are 4.5 million, and we are working as a professional margin on approx 32%. And globally, we have 12,000 plus partners, and globally they are our sales partners, and we are working with this partners in software and technology, different technology and contents online services portfolio, and across the worldwide we have more than 270,000 customers and across all the 11 domain industry, and you can say included at all 140 countries, and we have more than 25 million users. And one of the biggest game changers is in 3D experience platform. Why we say that 3D experience is the game changers? Because it's providing the single user platform for across all the industry domain experts. You can see that in the slides, right hand side, we serve all 11 domain industry, right, starting from the transportation and mobility to aerospace, defense, marine, offshores, life science, industry, equipment, high tech, construction, city, and energy and materials, and so and all available industries. So our GEOVIA portfolio come under energy and materials, and under this we'll take care of all our mining softwares and mining portfolio. And you can on right hand side you can see that 3D experience compass, and that compass our all the brands are stuck in that compass, and all the information it will provide you the single user platform for all the our existing brands and portfolio softwares to run in a single platform to smoothly all process transfer of your data flow from one user to different users. So GeoVia is also come fall into this compass and 3D modeling and apps. So this is the just basic overview of the Dassault systems. I request everybody to maximum utilization of this webinar, and I will hand over to Mr. Amjad Dacha for further technical discussions. Thank you everyone.
Thank you, Abhay. Thank you, Pramod sir. Thank you, Nitin. So today's agenda is we have done the corporate introduction, and I'll take you through the value of fit optimization through strategic mind planning tool. And after that, we will have a demonstration of the software. That's a strategic mind planning tool, and we will continue with the customer reference, which is MSPL Limited today. And after that, we will take your questions and answer those questions, as many as possible, and the way forward for it. So to begin with, strategic mind planning. What does it mean like strategic mind planning? Strategic mind planning is a tool which helps you to answer like how big your mine should be, where you have to mine, how much you have to mine, and when you have to mine. When is because nowadays you are seeing the commodity prices are fluctuating, your auction mineral blocks or getting mineral blocks up modus operandi has changed, and this premium has came, additional royalties has levied. So in these conditions, whether is it possible to do start the mining or to mine today or tomorrow? So it basically answers you to how, when, how much, and where you have to mine. And this strategic mine planning is not a left to right or right to left tool. It has to be an iterative process. That means if once you have created a scenario, it's not done. You have to do as many iteratives as possible to get the best NPV or best IRR of the project to determine those discounted cash flows, that is called as NPV. So the value of the strategic mine planning is to take the decision. So today we will be focusing on how this strategic mine planning helps you to take decision for bidding of the mineral deposits, and also to prepare a strategic life of mine plan for the greenfield or brownfield mining projects. So a lot of mining companies are still working, so it can also be used for preparation of strategic mine plans. To see any changes after every 5 years, we normally submit our mine plans to the Indian Bureau of Mines. So during this submission, again, we can check like what should be our long-term goals, whether it is aligned with the corporate objectives or not, whether in our current scenario, in current market scenario, whether it is feasible to continue the project, and if it is continuing the project, what should be the life of the project, what should be the NPV of the project, what should be the returns we will be generating. All this we can determine with the help of the strategic plan. And through how we will determine is like through determination of size of the mine. Size of the mine is not but your ultimate pit limit. So we have to determine the strategic mine plan work starts from like once you have established and evaluated your resource model. So from that resource model, the work starts. The resource model is the input for this strategic mine planning tool. So from that, we have to see how much we can mine, what should be our ultimate pit limit, and what should be our mineable reserves based on that. And you can do the techno-economic evaluation of the mineral deposit. It's not only like technical evaluation that is only taking care of your geological model and then giving a ultimate pit, but it also does the economic evaluation along with the technical parameters. And to determine the cutoff grade of the deposit, what should be your optimal cutoff grade. From marginal cutoff grade to the optimal cutoff grade, you can determine for the particular deposit. You can generate the strategic schedules to prepare a financial model so that you can input that financial model to your uh, evaluation for bidding mineral deposits. And you can determine the best possible NPV. And also there is a advanced tool called simultaneous optimization, which includes cutoff, stockpile, mine production, capex optimization, and NPV optimization. And also you can do the sensitivity analysis that we'll be explaining in the coming slides. So coming to the inputs for the pit optimization. Well, this strategic mine planning tool takes inputs not only the technical, it also takes the input of economical and regulatory. So in technical, you will have your validated or evaluated resource model that we call it as a tonnage grade model, in which you will be having your estimated grade material. You will be having a density defined in that. You will be having rock types defined in that. You will be having lithologies defined in that. You will be having the topography defined in that. So that complete resource model, which is evaluated, will be taking as an input for the strategic mine planning. And the other input and technical is your geotechnical parameters. That means slope angles has to be defined, because until and unless you ensure the slope angles, you cannot get the ultimate pit limit. So because it's not a vertical top-down kind of thing, so the mining the pit has to be in a particular slope which is operational, which can operate in that. So geotechnical parameters can also be included uh, in strategic mine planning tool, and you can have various methods to give the slope angles. You can give a single slope angle, you can give the slope angles based on the bearing, based on the rock types, based on any other parameters which are defined in the geotechnical study report. And also you can give the inputs of metal recovery, mining recovery, milling recovery. So these recoveries you can input into the strategic mine plan, so that you will get the exact mineable reserve, and also you can include the dilution. So while mining, you will have a dilution. So if you do not have the proper exact idea, you can give the dilution of an assumed or estimated dilution values. And also you can give the location constraints. So today, we after getting the mine lease, entire area we cannot get the permission. So initially you may be having the location constraints, like you have a forest area, or you have certain strategic area which cannot be disturbed in the initial period of the mining area. So you have location constraints in that. You have flora and fauna, you have village or something. So if you have these kinds of constraints, how you will determine your ultimate pit limit? So that's also a major, requirement in identifying the ultimate pit limit. So this strategic mine planning tool will take care of those location constraints also, while giving your ultimate pit limit. And also you can give the mining and milling capacity. Mining is your production capacity you can assign, whether it may be ore capacity or ore plus waste capacity, and also the milling capacity. That is your, either it may be crushing and screening capacity, or it is your processing plant capacity. So those capacities you can define based on your per annum consumption. And coming to the economical inputs, what we can give in the Whittle, in strategic mine planning tool, is we can give the mining processing costs, which includes the entire operation, starting from excavation, drilling and blasting, transportation, that is loading and hauling, everything, whatever the cost you incur in the excavation of rock up to the transportation to the plant. So that mining cost you can include it. That cost will be per ton or per cubic meter you can sign. And the processing cost is your, either it may be crushing and screening cost, either it may be your different process parts cost. So those costs you can define along with the cutoff grade. What cutoff grade, or what should be your minimum grade to be feed to the plant. And the overhead costs. So apart from that, you will be having the overhead costs like marketing or any other administration costs. Those costs can also be input into the SMP. And also you can give the capital estimation, that is capex, whatever the capex you are going to invest into the project. That's an initial capital estimation that has to be included in order to determine your net present value of the project. And you can give the discount rate, and also you can give the selling price. Selling price is nothing but your commodity prices. So if you are excavating at rock and you are processing it, after that what should be your selling price to sell the materials? That selling price you can give it as an economical input here. And other regulatory inputs are like you will be paying royalty per ton basis for the ore, and you'll be paying auction premium, since now it is an auction modus operandi for getting the mineral blocks. So once you get the mineral block, you have to pay the auction premium apart from the royalty. You have to pay DMF, you have to pay NMET, you have to pay other payments or taxes to the state governments or central government or Ministry of Environment, Forest, or any other statutory bodies. So these costs can also be included or given as an input into the strategic mine planning tool, so that you will not lose these costs, and then you will be getting exact internal IRR of the project. So these are the different inputs where we can give into the stat assembly tool. So once you have given these parameters, once you have entered all these information into the strategic mine planning tool, so you will get a nested pit shells. Nested pit shells is based on the revenue factor. You have defined the selling price. So let's say, for example, you have defined $100 as a selling price for a particular commodity, and what strategic mine planning does is it gives an option to define the revenue factor. That means with respect to the selling price, if your selling price is reduced by, let's say, 30%, then in that case, what should be your pit limit? If your selling price is increased by 10%, in that case, what should be your pit limit? So based on the revenue factors, you can control how your pit shells are defined. So based on the revenue factor, it generates a nested pit shell, a group of pit shells, which can be further used for generating the schedules, for selecting the optimal pit shell, which will be functioning as our ultimate pit limit. And for that, we have tabs we already defined, like economical parameters. So all those economical parameters will be given here. Along with the grade cutoff tool. So based on that, it will give the pixels, the range of pixels. So at the bottom, you can see the color coded has been given. So you can see pixel number 1, 2, 3 up to the like the pixels. If you have given a revenue factor of 2, so if your selling price is doubling, so what should be your pit limit? Because when your revenue selling price is increasing, that means you will generate more revenue. When you are generating more revenue, you can mine more, though your stripping ratio is high. So in that scenario, it will let you know, like in future, if your selling price is increasing, how much you can mine, what should be your maximum output limit, so that you can plan your fixed infrastructure like plant, offices, and all, so that it should not be in that particular boundary. Because in future, if you are going to expand the pit, then again you have to dismantle those permanent structures. Again, it will be costing to you, so it will be added to the project cost. So in order to avoid that, so this outer pictures, what we call like the bigger pictures, will help you to understand where your permanent structures has to be established. So once this nested pictures has been generated, so you will select one of the picture, and for further analyzing or further optimization, where you will determine your optimal net present value of the particular project. The input will be giving here is your initial capital cost. What's the capex you will be funding into the project? You will be keeping into the project, and what will be your terminal value. Terminal value is nothing but once your mining completed, and then what will be the terminal value of the project, because you will be having the machineries, you will be having the plant, you will be having the buildings. So if all those machineries, buildings, and all dismantled and sold, what will be the terminal value of the project? So that's the terminal value. And replacement capital cost. So you are started with certain machineries, so it has to be periodically replaced, like every 5 years or 8 years, those machines has to be replaced. So then you can give based on the time, like maybe after 8 years, you will be replacing the excavator. So 8th year, you can inject additional capital cost into that. So this way you can define time period. So it is not a fixed one. In strategic mine planning tool, it helps you to define your capital at a particular periodical time investment too. And you can define the discount rate per period, and also you can define the implicit time cost or explicit time cost. Implicit time cost is nothing but whatever the cost you are defining, whether it may be mining cost, processing cost, or selling cost, or other overhead costs and all. So that will be same for the entire life of the mine. So if your cost is changing, let's say after 2 years, your labor cost is increasing or your energy cost is increasing, then, for example, in the initial period, if you are starting mining today, you'll be paying, let's say, $10 per ton. And if it is increasing, your energy cost is increasing, then your mining cost will go up. So let's say at third year, you will have another $0.5 or $1 added to the mining cost. So the periodical cost, the time cost can also be given. And this explicit time cost is you can give as a whole value, or you can give to the particular cost like mining cost or processing cost or selling cost. So each separate also you can give it, or else you can as a whole you can give one value, so that at that particular period it will add to that value, and then it will optimize and give you the exact profit you will be generating from that. And after that, you have to give the like what should be mining limit and processing limit, and also throughput factors you can give. Like if you are sending material or sending ore to the process plant, and you want to send like rock types, by rock types wise, you want to categorize or you want to give the precedences or preferences to it, then you can assign those as a factor. So there is a tab called throughput factor. Through that you can assign those percentages, like a high grade material has to be if we do the plant more, low grade is less, so you can have those ratios and enter as a factor here. And even you can define the element limits. So in case of like copper or gold, you will have a limit of how much you want to produce. Like per month you are getting X tons of material, but you want Y grams of material as an output. So for that, how much you have to feed. So you can give the element limit, and accordingly you can see how much has to be fed every annum based on the grade variation what we're getting from the ore deposit. And from that you can generate the strategic schedules. Why strategic schedules important is your NPV. This schedule determines your NPV. For example, I've given one table here where you can see, let's say you have a project for which the life of the mine is 5 years. So you have invested $3 million into that, and every year you are getting the same cash flow, that is $1 million every annum. So for 5 years you are generating like $5 million. So the ultimate the net revenue is $2 million, but you have to discount it right every year. So if you are discounting by 10%, the discounted cash flow is after 5 years is $7,90,000. What if this schedule changes? Because this is what we normally do in an Excel file when we don't have a strategic mine planning tool. When we are evaluating our mineral deposits for the auctioning processes, we have the resources. We will just uh, assume that every annum we will produce 2 million ton or 3 million ton of ore, and for that this much of revenue will be coming. So that same revenue we will be keeping the same for the entire life of the mine, which is not practical. So when we are generating the practical schedules, second example, you can see the same investment we have made, that is $3 million, but your revenue is changing. In the initial period, you are getting more revenue, that is $1.5 million, and in later years, you are getting a less revenue. So this impacts your discounted cash flow. This impacts your NPV, because early revenue is most preferred because it gives more profit to you. It's quick cash flow. So in these both examples, you can see the second example is giving more NPV for that. But the first example is not practical, but we are doing in Excel with that. So that's why we are failing to understand like whether whether the organization will make the profit or not, and how it is going to make the profit. Whether we are under valuation, whether we are evaluating the profit of the project high or less. So under evaluating or over evaluating. So those kinds of things has to be cross checked by us before going for the auction or before giving the initial premium or basic premium for the bidding processes. And on the right hand side, you can see this is an example. So the strategic schedules you can generate in the SMP, and in graphically you can see how every period, that is every year, how your picture is there, what will be your how many benches are mined every period and all. And in order to generate the schedules in strategic mine planning, we have an algorithm called Milava. So basic algorithm, with the basic algorithm, you can have like with fixed lead, because when we are saying generating the schedule, so it should be an operational schedule so that these schedules can be operated. So we have a basic algorithm where we can give the fixed lead, that is vertical advancement rate per the period. Based on it, it will generate the schedules. And other than that, we have an algorithm called Milava algorithm, which helps you to optimize your schedules. So again, in Milava algorithm, we have two methods. One is Milava NPV and Milava balanced. Milava NPV is where it will try to find the method of mining, whether how the pushbacks has to be mined, because ultimate bit limit you cannot mine in one day, so it has to be in stages. So you have the pushbacks when you generate the pit shells, you have the pushbacks, so you can define the pushbacks. So either you can select the auto, the software has the ability to select the pushbacks automatically. If you are saying like if for 5 years you have a pit shell and then you want to mine it in a 3 stages, then you will define the number of pushbacks there, uh, or else you want to define user-defined pushbacks can also be considered here. So based on the pushback, so Milava NPV tries to find what should be the sequence, how those pushbacks has to be mined so that the project gets maximum NPV. But in that case, your ore and waste ratio will be compromised, because sometimes in order to maximize the NPV, what's basic thing is like you have to get the revenue, you have to get the more cash flow in the initial years itself. And the other Milava balanced is it tries to check which should be your sequence of mining, or how the cutbacks has to be advanced in order to have a controlled balance of ore and waste ratio. Uh, but in this scenario, your MPV will be compromised. So a organization has to decide which uh, is the major objective for them, whether the NPV or whether they want to balance it with balancing and NPV. So there are multiple options. You can create multiple iterations there and evaluate those strategic schedules here. So after this strategic schedule, for every pit shell, it will give the NPV, and also for every cost. So this is a graph where you can see in x-axis you have a pit number, that's a pit shell generated by the optimization, and right hand side you can see NPV, and right hand side you can see the cost of production uh, per dollar per OZ, and left hand side you can see NPV in $1,000,000. So each pit shell, for every mining cost or for every particular cost of production, you have a pit shell which is generating a certain amount of MPV. So it depends on the organization which pit shell has to be selected as their ultimate pit limit. If the organization wants to maximize their NPV of the mine, they can select the pit shell which is giving the higher revenue, higher NPV. And if the organization objective is like to produce below $225 per OZ, then the capacity of the mine will be increased, but it will sacrifice the NPV too, because when you are increasing your ultimate pit limit, you will be generating more overburden, and your lead distance will increase. So considering those, your NPV will be less. So it depends on the company objectives which pit shell has to be chosen. So this is the best example to understand that. And you can see at a particular pit shell, the max NPV is increased, after that it is decreasing, and there is a increase in reserves from the maximum NPV pit shell to the user required, or you can say the company which is targeted pit shell. So there is an increase in reserves, but there is a decrease in NPV. So these are the different criteria an organization can select a picture. And apart from that, like what we have been showing is for a single project. So what if you are having multiple mines and but you are having shared infrastructure or same infrastructure, like your processing plant, your crushing plant. If you are having the shared or same infrastructure for the multiple mines, uh, like your mining fleet and all, and it helps you to understand where and when to mine to maximize the values, because each mine you have to optimize and then you have to combine in Excel, but again that will not give value when you have the sharing infrastructure. So this strategic mine planning tool also has an option to include all the four mines and then run the strategic schedule there. So and other requirement is like we have to optimize the blending from multiple mines when you have a single processing plant. So that input grade will be same. So you have to optimize the blending for multiple mines. So from which mine, how much you have to produce, what kind of material you have to produce every period, that is every year, so that you will get a constant grade to the plant. So that needs an optimized blending, and you can use the same resource model or you can merge all the resource models. Let's say if you're having three mines, so you can merge three mines resource model into the one model, and you can do the optimization process, or else you can use the same model, so that it has a drop down option for each mine. You can select that resource model, and you can choose different final pits or stages for each mine, because when you are targeting for the process plant as a particular quality or maximizing NPV, so your pit stages of final pits will be different for each mine, and you can give the individual mining limits. So one mine you can produce, let's say, 0.5 million ton, another mine is producing 1 million ton, the another mine is producing like 1.2 million ton. So you can give the individual mining limits there, and also you can delay mining in a specific time. Let's say first mine you got all the approvals, but for the second mine, uh, the approval is delayed for 6 months. So you can give the delay in mining for a specific time. Also in between, if you are having like water issues or something, then you can include that also as a delay there. And next is coming to the strategic mine planning's advanced strategic scheduling tool. So whatever the optimization and the strategic schedule we have generated, we have evaluated each stages. Like we have generated the schedules, we have evaluated the cutoff, what should be the cutoff for to get the higher NPV, stockpiles, blend. So we are doing step by step. But this simultaneous optimization does is it will simultaneously takes the inputs of all, like cutoff, what should be stockpiles, what is your mining sequence, in which direction you want to mine, and what's the process throughput factors, blending parameters, schedule parameters. All those it will consider, and then it will generate a single schedule. So there is no need to validate one step by one step. So it will validate all those parameters, and also it helps you to maximize the capex. Let's say in future, if you are increasing your mining limit, so for every ton of increase in the mining limit, what will be your uh, investment per ton, so that you can give it, and then you can see what how you can optimize your capex. So for example, from 1 million to 2 million ton, if you are increasing your mining production, and then for example, let's say your mining cost will increase by $1, then in that scenario, how much capex you will require and how your NPV varies. If it is $2 per ton for the increase of the reserves, then what is the impact on NPV? So this way you can optimize your capex too, and it unlocks the hidden NPV, because you are evaluating all the parameters in a single go. So in that way, it unlocks the hidden NPV where you're missing in single steps there. And this is an format of simultaneous optimization. That is, we call it as a SIMO, SIMO spreadsheet reporting. So once you have done the optimization, it will generate an Excel report where you will have summary of costs, revenue, summary of the material, summary of all the paste. If you're having a multi-mine model, it will give summary of all the paste, whatever the raw material you have mined, what's a process you have done, what's a cash flow you are generating, and all. It will give in a single Excel sheet. And you will be getting the reports of same. And the next one is you got the NPV, but you want to check what parameter is most sensitive for your project. Like you are giving a mining cost, processing cost, but what happens in future if your mining cost increases or decreases? What effect, what impact it will give onto the NPV? So you have to observe which parameter is very sensitive or which delicate. Uh, so that if that parameter changes a little bit, let's say even for $1, it may the NPV changes is very much more than what is permissible. So in right hand side you can see there is a red line, so which is of price for AU, that is selling price of gold. So you can see selling price of gold in this particular project is very sensitive. That means if your commodity price is changing, so that means you have to again rerun your scenario, and you have to check whether you are going into the right direction, whether your current mining schedules or certain long-term schedules is in line with your corporate objectives, how your profit changes if that selling price is increasing, let's say by 10%, how much percentage of variation in your profits. So all those has to be checked. So this sensitivity analysis through spider graph, it helps you to understand that, like, for your project what parameter is most sensitive. And the best practices workflow in mine planning is once you have evaluated resource model is to generate the pit shells and to generate the strategic schedule so that you determine optimal NPV by giving stagings, limits, that is your mining or processing limits, throughput limits, minimum mining width, or you can also give the minimum mining width so that your ultimate pit limit, pit having the minimum working width at the bottom bench. You can give the cutoff grade to stockpiles, materials. You can generate with all these inputs. You can generate the strategic schedules, and you can select the pit, which pit will be your ultimate pit limit based on your objectives and the stages. So you can select the stages to that is pushbacks in order to achieve the ultimate pit limit. And you can transfer it to the general mine talent package, like pack for the pit designing and the tactical schedule for generating your long-term or short-term schedules for generating the executable plans to operate the or to excavate the mineral there. Okay. And next is like the strategic mine planning also has a value. Like you can do this data centralization and collaboration. So there is a web-based platform called 3D Experience platform. So onto this platform, you can centralize your data and you can collaborate like for evaluating your mineral deposit for the auctioning processes. Various departments works. Let's say finance will work for the costing part, geology department will work for preparing the resource model, and engineering department works for the generation of strategic schedules by taking inputs from geology and finance. And the leadership team again evaluate the financial model which you have created. So all the departments are currently running in silos. So all those departments need to be collaborated. So that you will get a better value. So that the work, there is a track on each work who is doing what and all. And also there will be a single version of truth, because when when you have a tracking of the file and when you're able to see which file is prepared by whom and all, which file is final file, because you have prepared a financial model. If 2 or 3 people are preparing a financial model, if one person is preparing a financial model and he will not prepare at a single time, so he may be making changes based on inputs from finance or geology or any other departments, and again he will be making changes continuously, and but certain time you will not be able to say which is the final sheet, or if he has made changes in the final sheet, then recovering the previous or earlier sheet is difficult. Earlier financial model is difficult. So this 3D experience platform will help you to recover those files too. You can able to it saves the files as a date and time files, so that you can have a record. You can have a single version of truth there. And it is a device agnostic. That means in order to run this 3D experience platform, you don't need any uh, like controls or anything. So it will basically work on a browser. So on a tab or in laptop, in your personal desktop. So you can open your browser and then you can operate on the browser itself. So this 3D experience platform is a web-based platform. So you won't need any connectors, any installations or nothing. So this will be very helpful to to have the additional values, to have the collaboration of all the departments and get those values. And next one is like we have simultaneous apart from the simultaneous optimization, we have a simulation tool which further enhance the applicability. Like you have given the parameters like mining cost, processing cost, capital investments, and all you are giving as a fixed cost, and then you will be changing the parameters. You are generating the schedules again. So you have to create scenarios multiple times. What if software helps you to let's say if whatever the input parameters are there, this simulation application helps you determine like which parameters are best suited for what mining cost is best suited, what capital investment or direction, which direction is best suited. So it basically this tool basically runs hundreds and thousands of scenarios, and it will give the best result to you to determine that. So I'll run this video. It's only for a couple of minutes here. So this is how your data collaboration free. So it has user-based access. So you can control which user can edit or which user can view, which user can work. So you have the user-based access here. And this is a collaboration. So if you have given a task to the finance or to the geology team, so you can track those, or you assign those tasks, and you can review the files if shared with you. If a geologist has prepared a resource model and then you want to review it, so you don't need to install any of the software. You can review in the platform itself. And then you can work with optimization strategic schedules in the strategic mine planning tool. So this is the entire strategic mine planning tool workflow. This is again, I'll show it in the demo here. Okay. So once you got the results and all, so you want to optimize what will be your optimal mine capacity to fit the process, at which fixed top grade will be your having maximum NPV. So in order to determine that, you have to create multiple scenario and strategic mine planning tool. But when you are combining this simulation application with that, so because in platform you have multiple apps, like in mobile we have apps, so you can use those apps and then you can generate it. So this design of experiment or simulation tool is one of the application which helps you to determine or which helps you to simulate those options for you. So it will iterate the combinations of mine capacity, process capacity, at cutoff grade, and any other parameters you define. And you can also adjust these capex and opex for each production scale iterations. And basically, you can create you can design a workflow how your simulation has to be done. So that workflow can be defined by the user itself. So you can define the parameters, you can run the strategic mine planning tool, and then you will have a simulation, or you have design of experiments and all. You can simulate it with the different techniques like Monte Carlo, Six Sigma and all, and then it will give you the best result here. So you can see into the graphs, you can review the results graphically, including scatter plots or charts or bar. Yeah, it's taking time. So this is about the simulation, and coming to the like strategic mine planning demo. So this is the tool. I'll finish it in like within 5 minutes itself. So this is a tool where you will import your resource model. So you can see here the resource model dimensions are 30, 30, 30. That means X, Y, and Z. Z is nothing but your bench height. That is given as 30 meter here. And model frame wide direct dimensions. What is your length and width of your block model and depth of your resource model. And what and the summary is like based on the rock types like oxides or practical oxides and mineral oxides, ore mineral and all. So it will be the rock type wise ore tonnage available in the resource model and total units you are having. So this is basically a copper project, also having a copper gold project here. So this resource model is a initial input to the strategic mine planning tool, and after that you have to assign your geotechnical values, that is your slope angles. So you can define the slope angles by slope regions, or you can by zone numbers, by rock types. Here, based on the bearings, the slope angles is defined like 0 to 90, 45 degrees, and after that, you will be having 40 degree in that region. And you can define the maximum benches for the slope angle generation. Like in order to achieve 45 degree for ultimate width, so you have to mine minimum 8 benches here. So there is a thumb rule if you calculate the number of benches for it. And again, you have to generate the pit shells for the pit optimization. It uses Slush-Grossman algorithm, where it takes care of your all the costs like reference mining costs, your recovery, dilution, your processing costs, and grade, cutoff grade, selling costs, and selling prices, and you can give the revenue factors, stages there. What will be the minimum and maximum fixed factors we can give. So based on that, it will give an output. It will generate a nested pit shells, and for each pit shell, it will give like how much rock is there. Rock is nothing but ore and waste. From it, how much ore you can able to mine it. What will be your stripping ratio? How many benches you are going to mine in a particular pit shell? What is the total units or gold units or copper units available, and what's the grade of it? So you can view it, and there is a 3D viewer, so you can view those pixels in a 3D viewer, so that you can able to see how your pixels are advancing. Okay, so you can see the pixel is increasing, like 15, 16. Whatever the number of pixels are there, you can view it, and also you can view it in different planes, either XY plane, XZ plane. You can see these pixels here. So the color codes, you can have the legend from the pit info here. So it will show you the legend. You can change those scales also. So you can change the legends. Okay. So once you got the pit shell, then you have to generate the schedules. You have to determine your optimal NPV. So for that, you have to assign your initial capital cost you are going to invest. You can see here $250 million has been invested into this project, and at a discount rate of 10%. And the mining limit here is 6 million ton, and the processing limit is 2 million ton. So based on those parameters and the schedule parameters, what should be your fixed lead? Fixed lead is nothing but maximum number of benches you will be mining per a period. So here it has given 4, and manual view. So pushbacks in order to go up to the ultimate pit limit. So you can define your pushbacks, or else you can define an auto option. So the software takes care of selects the pushback by itself. So based on those parameters, you will generate the pictures. You can see in a graphical tutorial, you can see like in each period, if you have selected a particular ultimate picture. So for that, It is having like more than 13 years of life. So each year you are having 6 million ton of ore. You are mining 6 million ton of ore. For that, the gray part is your waste rock generation here, and the red line defines like grade of copper, and blue line is your grade of gold. Okay. And in summary, you can able to see for selected pit shell, that is for pit shell number 31. If you're mining that, if you're going for that, then you will be having an NPV of 4,500 million US dollars, and life of the mine is a little less than 14 years, and payback year is 3.84. That means within 4 years you can pay back the entire capex you have done the investment, and the payback ratio, that is payback year by the entire life of the mine, and IRR of this particular project is 31.67. So this is how you can determine the optimal pit limit, and optimal NPV, determine your life of the mine, IRR. Okay. And coming to the these many iterations you can do. You can change the parameters. You can change. You can select the Milava options. I'll just show you one option, like in Milava balance mode. So when you are going for the standard one, like you have given the vertical advancement rate of 4 benches, and then selected a picture, you have generated it. In that, you have varied waste generation here. So there is no constant or stupid ratio here. So when you use Milava balance mode and select the schedule parameters, it generates a schedule. Every year your ore is same, ore generation is same, but waste also it tries to control it. So you can see your waste is same in the initial 6 years. I think from 7th year it is shooting up, but again it tries to balance those ore and waste ratio here. So this is how you can use those algorithms, and in simultaneous optimization, you can give all those prices. You can define your blend bins. You can define your stockpiles to optimize your grade, to optimize your cutoff grade, and then you can generate the schedule from that. So instead of validating each and every step, you can take all the inputs and then you can generate the schedules here. So this is how a strategic schedule, simultaneous optimization schedule looks. Where you can see LO is tonnage mined and feed it to the plant, and you can manage the stockpiles too. So dark LO is your tonnage from the stockpiles to the process. So directly from pit to the plant it will go, or from stockpile to the plant. So based on the requirement or based on the grade requirement you have defined there. Okay. This is about the software. Due to time constraints, we are unable to show it detail into the application. Okay. Now I would request Pramod sir to.
Yeah, Amjad, thank you. Thank you very much for your presentation. We are just a little bit above our timeline, so I think it will take few more minutes to hear about the benefit. What I think our esteemed user MSPL is getting by utilization of the software. So we'll hear from Mr. Madhav Acharya sir. So over to Madhav Acharya sir. You can just share your experience, how you are getting benefit by utilizing the solutions. So that it will be definitely helpful for the audience to take it further for their own minds, because you are also working for a similar kind of projects. Yeah.
Yeah, a very good afternoon to everyone. This is a copper case study that I have taken here. I think most of the technical part that has already been covered by Amjad Basha. So I will not be taking so much time, and I have only prepared 3 slides to highlight what exactly we are doing here in MSPL. So this GEOVIA Whittle software, for the last couple of years, I am using it not only for the auction blocks, but also for the overseas greenfield, brownfield project. So close to 60 to 65 mining project that I have already been evaluated. We are getting very good result. This is fantastic actually. So here I have taken one case study. If we see in the left side, this is a copper deposit, particularly that is in India. Okay, that is in India. This is a copper deposit, and we have established the resource model. We have for that we have run that resource model into the Whittle pit optimization software. Here you can see here there are a number of ore loads that has been clearly marked, and these are the ore bands you can see, and you can find here the ultimate pit cell that has been generated from the Whittle software. On the right hand side, if we see, this is a typical block model cross section with the ultimate pit outline area. So here you can see, even if your ore body has gone up to a depth of 300 meter from vertical from the surface, but your pit has gone up to maximum of 140 meter depth. Here that means it is easily you can get the mineable part of the resource here. So particularly in India, so there are people, most of the people that talk about the geological resource and mineable reserve. So I suggest, and I also request everyone, if someone like if you use this software, that it is possible to get the mineable reserve straight away from the geological resource by providing minimum to minimum parameters. Okay, so what are the basically the technical and the prerequisites you can say. So there is a validated resource model must be updated with the latest pit survey. Topography must be provided, and highest and lowest MRL of current ore body that has to be given. And then the resource model that must include your ball density for ore and waste, and there must be some different type of litho and litho core, etc. And then the ultimate pitch slope angle, again that is the geotechnical parameters that has to be provided. Okay, and you have to make sure whether that is like it will be constant for the entire pit or it may vary. Okay, so there are certain sort of things that you have to take into consideration. So main benefits, if we see here, because of those things, the time value of money is the essence of evaluating NPV. So strategy mine planners find it difficult to decide if the right time to mine a block of ore depends on its value, but its value depends on when it is mined. When is the right time to mine it? So this is the big question for the strategy mine planners. So here, the conversion of geological resource to mineable reserve is possible with the valid input of all the technical and economic parameters. So it will take care of any mining constraints where mining will be prohibited in the leasehold area, like permanent structures, high tension electric lines, rivers, any public roads, etc. etc. It will also take care of geotechnical constraints based on rock types, strengths, and accordingly different pitch slopes can be provided. And here the year-wise mine production schedule, that's the most important part. Here the year-wise mine production schedules that is being generated from the highest revenue factor 1 pit, which includes your ore and waste tons, grades, strip ratios, will help in deciding revenue and cash flows precisely year on year without any bias. So here, if you'll get different sort of different type of tons of waste, so your cost of mining will differ. So again, here this is it will determine the economic viability of the deposit, expected NPV, and the expected return on investment, as you will get the optimal extraction sequence. It will determine the economic viability, expected NPV, expected return on investment with the optimal extraction sequence. The sequence and the rate of mine production, early access to high value material, delaying waste and development cost, prioritizing the value without compromising the future of the operation. So it will define the strategic direction of the mine, because there you'll find a cutoff grade and you can optimize your cutoff grade as well. So this is basically I have provided one Excel output from the Whittle as we generate the year-wise schedule that can be fed into a financial model in Excel, and that will be more precise and accurate. And the calculation of NPV, project IRR, and sensitivity of all mining projects that being e-auction. Here you will find all this year-wise schedule. Year on year, let's say you are going to mine this much of ore and waste, and you'll find the strip ratios and you'll find the grades. Okay, and here you'll find the discount of your output. So this you can make your financial model, and all the bidding parameters will be decided based on that. So thank you so much. Yeah, that's it. That's from my side. Okay.
Yeah. So it's very good means presentation from your end, means the benefit what you are getting from the software, mostly on the operational mines as well as from the e-auction. So that is the two major point which is mostly means important for the mining industry to find out how economically they can able to mine the means their project and all these things. So definitely it will be help for the other participant. They can also think of their projects, how they can get benefit by utilizing the technology or the software. We hope that if any such type of requirement from the audience or from the participant is there, means our team and ourselves will be there ready to guide them and support them how best they can utilize the software. Now over to Nitin so that I can close the session.
Thank you very much, everybody. Thanks, Amjad and Acharya ji, for wonderful presentations, and thanks on behalf of the Dassault system and EDS technology. Thanks for your time.